Hello guys. So today we're going to start on a new chapter. This new chapter is on data analysis. So it's time to look at data. Okay. So what you'll be learning today is on the cumulative frequency diagrams. Okay. So there are a few things you need to learn about cumulative frequency. Hopefully by the end of this lesson, you'll be able to appreciate this a little bit better. Okay. So let's begin. So highlight this cumulative frequency table. You will see this very frequently. Okay, so follow me here. Right, let's start with a scenario base to understand this a little bit better. It is going to be very, very useful for you, okay, if you learn the cumulative frequency well. Okay, now let's start with this scenario. One day, a farmer collects 330 eggs from chicken she has reared. Okay, wow, that's a lot of eggs, right? She categorizes the mass of the eggs using a frequency distribution table and represented them under a histogram. So, the farmer put the eggs in a table and a histogram. Okay, so she put the eggs in a table and a histogram. So she used two different ways to represent it. This one and this is two. So now in these two ways of representing, the one on the left hand side, she put between 35 to 40 grams. There are 20 eggs. 40 to 45 grams. There are 60 eggs. So now let's focus on these two. Over here is between 35 and 40, right? Okay, so you see that there are 20 eggs, 60 eggs here. This is 40 to 45. So in other words, she is using two different ways to present the data for her chicken eggs that she collected, okay, by the mass, and it's between it's the difference is 5 gram, 5 gram, 5 gram, 5 gram lah, huh? So she used two different ways to present it. First, she used table. Then after that, she also used a histogram. Okay, so these are two ways that she used. Now suppose she wants to categorize the masses lower than a particular value, such as this. Now what if she don't want to, like, separate to 35 to 40, 40 to 45, but rather, okay, I want you to look carefully together with me. Rather than having a range like that, okay, 35 lower limit to 40 upper limit, she just want to know how many eggs are there below 35, how many eggs are there below 40, how many eggs are there below 45, so on and so forth. Okay, so she don't want to categorize by 5 gram, 5 gram, 5 gram. She want to have just one range, less than, less than, less than. Okay, so if she want to do it this way, how can she do it if she want to put a table like that? Now, if you want to do that, then you will realize that you have to add up the frequency for each category. Because you look at the first one, how many eggs are there below, let's look at the first one. How many eggs are there below 35 gram? 0. Don't have. How many eggs are there below 40 gram? 20. Okay, because you look at the table here. Then how many eggs are there below 45 gram? So we look at this number. Below 45 gram, I will have 60 and I will also have 20. Okay, because based on my table here, I also have the 20 gram inside. Have to be included. Okay, because below 45 gram means that I need to take everything that is under 45 gram added together. Now another way easier to see is to look at this table. If I draw a line here, how many eggs are there below 45 grams? Total will be 60 plus 20. Okay, so that's what it means. So therefore, if let's say she wants to categorize it this way, she need to add up all the frequency. Whereas for this 50 and 55, likewise, you have to do it that way. Okay, so if you are going to use less than as to represent your data, then you would have to use this thing called the cumulative data. The word cumulative means that you accumulate. You just keep on adding on and adding on and adding on, where you put them in a cumulative frequency table. Now I want you guys to go back to the previous words here. Take note. This is called a frequency distribution table. Can you follow me? This is called a frequency distribution table. And today you're going to learn a new table that is called a cumulative frequency table. We add in a word cumulative here. Okay, which gives us the information that is less than or equals to something. This is the function of a cumulative frequency table. Now, using the new requirement to write a table, you see that the farmer put the numbers as what according to what we have just now is this. There's no eggs that's below 35 gram. Below 40 gram, there are 20. Below 45 gram, if you look at the table before that, you see that this is actually 20 plus 60. Below 195 is actually the number here. Everything before it is 20 plus 60 plus 115. Okay, because under 50, you just have to take a look. You draw the line here. I'm going to take everything add together. Then if it's 55, I'm going to draw the line here and take everything that is in front. If you do not have the histogram, then you just have to draw the line and everything here add together. Okay, because everything under 55 is less than 55, right? So you need to add all of them together. So in other words, when you draw it in a histogram, this is how it look like. Okay, you will all add up, and the final number that you have should always be tallied to the total number that you have for the x, because cumulative means that at the end, the last set of data should show the final number, the total number of x that you have, because it's cumulative. You cannot adding and adding until you have nothing else to add. So the last category should have the last egg inside. So it should show 330. It cannot be more, it cannot be less. So this is what it means. In other words, the number will only get bigger in a cumulative frequency table or a histogram. Okay, so you have to, so the key point is here, the number of the frequency will always be increasing, because you're always adding on and adding on. You can probably at some point add nothing. Okay, I repeat, you can probably at some point add nothing, but you cannot minus anything out because you'll keep on adding and adding, right? You can have one category that have nothing, 0, then okay, plus 0, but the next category we have to add something else. Yeah, okay, so I will stop this video here, refer to the next video for page 2. Okay, thank you.